Hello everyone, welcome to my channel. Today you are going to perform a simulations on a solid steel shaft having two pulleys. This is a problem of Shigley Mechanical Engineering Design book. Our main aim is to compare the calculations made by Shigley's with our simulation results. So here is a shaft that is the that has three segments. Each segment has a length of 10 inch and the diameter of the shaft is 1.5 inch. As the pulley B has a diameter of 4 inch while pulley C has diameter of 8 inch. The two forces are applied at the pulley B that are generating a bending moment or torque. Similarly, two other forces are applied at pulley C in y directions, and also they are creating a bending moments. So we will compare our results of simulation with the calculations made by Shigley's. We will compare the reaction forces at point A, at point D, as well as moments in the plane 1 as well as in plane 2, and similarly we will also compare the maximum bending stresses as well as maximum torsional stress between the pulleys. So let's start our simulation now. So first of all, we will make a sketch on the front plane. And we will draw a lines, three lines of length 10 inch. So just draw three lines that are equal in length. Add equal relation and assign the dimensions, that is 10 inch. Now exit from sketch and go to the weldment module, then structure member. Here we will assign a profile, that is ISO, and that is the pipe from the type, then size is 21.3, and the groups, select these three lines. Okay, so we have assigned a circular profile to this problem. If we go to the problem statement and see what is the diameter of the shaft, that is the 1.5 inch solid steel shaft. So we will change the profile shape to 1.5 inch in dia. Also note that the pulley B is 4 inch in diameter while pulley C is 8 inch in diameter. So just change, go to the structure members and then change the profile of all these three members. As our shaft is solid, so delete the inside circle and change the diameter of this circle to 1.5 inch. Exit from sketch now. You can see we have changed the profile of these three structural members. Now you will add the simulation module in SOLIDWORKS environment. So simulation tab has been appeared here. Click on the simulation and start a new study. Give a specific name and select static from the general simulation type. Okay. So we take the front view normal to our screen. Here if you go to the parts and the cut list, you can see we are treating these all structural member as a beam. There are 3 beams and then 4 number of joints. 2 number of joints are free, are at free ends, and 2 are at in the middle. First of all, assign the material to this shaft members, that is alloy steel. And if you go to the problem, you can see that this shaft is simply supported at point A and point D. So we will apply a simply supports at both points. So go to the fixtures and select immovable. Then select this one and this joint. Okay. After that, you can see that total force of 1200 pound force will be applied in Z directions, while the 600 pound force will be applied in the Y direction. So we will apply a force of 1200 pound force at point B. Go to the loads. Then select this joint. You can see the force will be in the Z direction. From here, select the reference geometry, that is front. Change the units to inch pound and increase the symbol size so that you have clear visualization. You can see the direction of the force being applied is Z directions, and that is 1200 pound force. After that, we will apply a force of 600 pound force at the joint C in negative Y direction. Again, go to the loads, then force, then select the joints, select this point C, and from the reference geometry, select front one, change units to English, increase the symbol size, reverse the direction, that is 600 pound force. So we apply force of 1200 pound force in Z direction and 600 pound force in negative Y directions. And after that, the moment that is being produced due to this force as well as this force, here is the moment in the clockwise movement, that is 1600 pound force, and here is the moment that is anti-clockwise, that is 1600 pound force. So again, go to the loads and select the torque, select the joints. From here, select the front plane, change units to English, and movements in X direction. So select this one, change the symbol size, to 500. You can see if we reverse the directions, so this is the, as you can see, this is the counterclockwise. You can see the direction. This is the thumb. The value of moment is 1600 pound force. Again, just make a copy of this moment. Click here, then paste. Go to the edit definition, and from the joint clear it and select this joint, but with the reverse direction. So solve the simulation study now. So our simulation has been completed. So if we go to the Shigley calculations, you can see that the reaction forces at point A is 800 pound force as well as 200 pound force. 800 pound force in negative z directions and 200 pound force is in positive y directions, while minus 400, that means is negative z direction at point D as well as 400 pound force at in the y directions. So we can compare these both reaction forces at point A and D of this shaft with our simulation results. Just right click on the results and list result force. Change units to English. From here, select this point and update. You can see the reaction force is 200 pound force as well as minus 800 pound force, that means in negative z directions. That is same as that of Shigley calculations. Similarly, if we click this point D and update, you can see the reaction forces, and at point D is 400 pound force in both directions, in positive y directions as well as in negative z directions, as you can see here. So our next step is to compare the bending moments in direction 1, in plane 1 as well as in plane 2. You can see here for one case the bending moment is maximum, that is 400 pound force at C, and is another case is the maximum, that is 800 pound force at point B. So again go to the beam diagrams. From here select the bending moment in direction 1 and change units. You can see that bending moment is 4000 pound force, that is maximum at point C. This is the case, this case, that is maximum, that is equal to 4000 pound force, similar to our simulation results. And if again go to the define beam diagrams and go to the bending moment in direction 2, you can see that is maximum, that is 8000 pound force at point B, that is similar to that of the Shigley calculations. So reaction forces as well as bending moments are similar to our Shigley calculations as well as our simulation results are same. And other things that you have to calculate, that was the maximum bending stress, that is 24,890 psi by Shigley. The maximum bending moment is this, as we see in the graph, and the maximum bending stress at pulley B is this. Similarly, another parameter, that is maximum torsional shear stress that occurs between B and C, and its value is 2414 psi. So we will compare these both values, this one as well as this one. Again, go to the SOLIDWORKS, click here, define stress plot, change units to psi, and from here check the upper bound bending in direction 1. That is not compatible with Shigley calculations. If we check the bending stress in direction 2, you can see that bending stress is maximum, that is 24,000 psi, that almost occur about point B. As you can see that the bending stress is maximum at the pulley B, that is 24,890. That is very close to our simulation results. Similarly, if you go to the torsional stress or shear stresses, go to the torsional, you can see the torsion stress is maximum between point B and C, that is 2414 psi. And if you go to the our calculations of Shigley, that is similar to that of our simulation results. So in this way we compare our simulation results of this shaft with two pulleys. We compare the moments, reaction forces, shear forces as well as bending stresses. I hope you enjoyed this lecture. Please ask me any questions in comment box. Thank you for watching. Take care. Bye bye.